Okay, this is your Unit 2A test review. I'm going to go through it as quickly as I can. Remember, this is going to be a fairly long video though, so if you want to watch it in spurts, that's fine. Also, please do not watch this video until you have actually done the review on your own first. It's going to do you no good just to copy what I do, so make sure you're doing it on your own first. All right, the directions here tell me to simplify. Okay, simplify means I'm going to get my numbers or my expression, and here's the other clue in here, it's an expression, okay? I'm going to get my expression to be as simple as possible. Now in each one of these cases, basically what it's meaning is I'm going to get rid of any parentheses I have. In addition to that though, if I can combine any like terms, I'm also going to combine like terms. So in this first one here, this is distributive property. I need to do 6 times m, which is going to give me 6m. And I have 6 times -5. Well, that's going to be a negative answer because a positive times a negative is a negative. And 5 times 6 is 30. So this here is my final answer for that because that is as simple as it gets. I can't subtract the 6m and the 30 because there's a variable involved. So that's as simple as it gets. This one here, number 2, looks the same, except the only difference is they have the 4 after the y plus 9. So I can do it this way. It's going to be -4 times a positive y gives me a -4y. And then again, -4 times a positive 9, which gives me a -36. And then this is my answer here. That's as low as it goes, or excuse me, as simple as it gets. So there's my answer there. Here, same thing. I'm distributing. But it's going to have, it's a -8 times a -4. Okay, that's a negative times a negative, which is a positive. So 4 times 8 is 32. And again, I have a negative times a negative, which again is a positive. So it's going to be a positive 8k. Now, the only thing is, I've mentioned before, whenever you are writing expressions, you should have the term that has the variable first. So what I really should do here is just kind of switch this around. This is a positive 32. This is a positive 8k. So it's going to be 8k plus 32. And then this is actually my final answer right here. If you left it as 32 plus 8k, that would be okay. I'm not going to take off. All right, we're doing the same thing here, still simplifying. Here now, though, I need to combine my like terms. So remember, circle your terms that are the same. On this first one here, I have a positive 6c, and on this one here, I have a negative 5c. Okay, well, basically, it's positive 6 minus 5, or 6 minus 5, which is going to be 1. So I have a -7 plus c, because it's a positive 1c. I don't need the 1 in front of the c. In addition, though, to switch that around to put the c first, because again, the variable should be first, or the term with the variable should be first. So look at the integers we have. It's a positive c. It's a -7. So that's going to be c minus 7, because that negative sign right here becomes the minus sign in our answer. So this is my final answer. If you left it as -7 plus c, that's okay. This one I'm going to do on number 5, I'm doing a little of both here on this. I'm doing my distribution, and then I'm also combining like terms. I have I'm going to put the negative n because nothing's going to happen to that yet. I have a positive 7 times n. That's going to be a positive 7n. And then I have a positive 7 times a -4. That's going to give me a negative answer. And then 4 times 7 is 28. Okay, this is not simplified. It's not fully simplified because I still have n's in 2 different terms. I need all the n's to be together. So I have a negative n here, and I have a positive 7n here. That really means I'm doing 7 minus 1n, or 7n minus 1n. That means I have 6n minus 28. There's my final answer there. Okay, here I'm actually solving my equations now, and I have to show all of my work. Remember, just to get full credit, I need to make sure I'm showing all of my work. So on number 6, I'm going to get rid of the 12 first. These are just two-step equations. Remember, we're getting rid of whatever's a lone first. This is a positive 12, so I'm going to minus 12 from both sides of my equation. This cancels out. I have to circle what I would suggest, circling what you have left. You have a negative 5y left. So I'm going to rewrite that as negative 5y is equal. And now I have a 3 minus 12. 3 minus 12 is negative 9. Because think money, too, when you're doing your negatives. I have $3, but I owe somebody $12. Well, I can give them $3, but I still owe them $9. Okay, I now need to get rid of my 5, my negative 5. So I'm going to divide both sides by negative 5. Because I'm trying to get rid of it. This is 5 times, or negative 5 times y. So I do the opposite, or the inverse operation to get rid of it. Now, a negative divided by a negative gives me a positive, which is great, which is what I want. So I have a positive y. That's all I have left here. And I have to do it on this side, too. Again, a negative divided by a negative is a positive. And 9 divided by 5, I'm just going to leave it as 9 over 5. Remember, we can leave a fraction as an improper fraction, and that's perfectly fine. Number 7, I need to get rid of the number that's alone first, and that's the side with the variable. So negative 7 is what I need to get rid of, which means I'm going to add 7 to both sides of my equation. This cancels out, and I get x over negative 4 is equal to 2. Because negative 5 plus 7 is 2. Now I need to get rid of the negative 4. Since I'm dividing by negative 4, I need to multiply both sides by negative 4. In this case, it's negative 4 over 1. In this case, it's just negative 4. This cancels out, and I'm left with x is equal to negative 8. And there's my answer for that. Number 8, before I do anything, I need to combine my like terms. Remember, if ever I have that to do, I need to get that done first before I start getting rid of anything. So we're going to subtract, we have m minus 2m. m minus 2m is negative m. Because this is a positive m and this is a negative 2m, so I get a negative m when I'm done here. Minus 3 is equal to 12. I now need to add 3 to both sides to get rid of the 3. That means I have negative m is equal to 15. Remember, I cannot have a negative variable. So if you wanted to, you could have gone back here and actually said this was a negative 1m. This is a negative 1m here, because now I know I need to do my final step of dividing by a negative 1. That cancels out, so I get m is equal to negative 15. The other thing we could have said, though, negative m is equal to 15, so a positive m is equal to negative 15. You can kind of do the inverse or the opposite there. Okay, on this one here, we need to combine our like terms and move all of our like terms to one side. So I have negative 4f on the left-hand side, and I have a positive 4f on the right-hand side. Well, I'm going to move this one over. That's what I want to kind of get rid of, because if possible, we want to keep all of our variables on the left-hand side. So I'm going to put my equal sign here. I'm going to subtract 4f from here, which means I'm going to subtract 4f from here. Be careful with this one. It's going to be a little tricky. I have negative 11 left, so this is negative 11. Now, negative 4 and a negative 4, if I combine those, I'm getting more and more negatives, because remember, two like signs, I add them up. So negative 4 plus another negative 4 winds up being negative 8. So I have negative 8f plus 11 is equal to negative 11. All right, now I'm going to get rid of the plus 11, so I'm going to minus 11 from both sides. The right-hand side is going to work like the left-hand side just did. This is going to be negative 8f is equal to negative 11 and negative 11. Remember, when we circle our integers, it kind of then tells us what we need to do. If you're having any trouble with our integer operations, you need to make sure that you're going back and looking at some of those videos on integer operations. So we have negative 11 plus another negative 11 gives me a negative 22. Okay, now we need to divide both sides by negative 8 to get rid of my negative 8. So negative divided by negative is a positive, which is great. I have a positive f. And again, a negative divided by a negative is a positive, but I can reduce this fraction. This becomes, 2 goes into both of these. This becomes 4, and this becomes 11. That means I'm winding up with 11 over 4. But it is positive because it's a negative divided by a negative, which gives me a positive. I can leave my answer as an improper fraction. That's perfectly fine. Okay, on number 10 here, I need to get the g's all on the left-hand side. So I'm going to subtract 2g from here, and I'm going to subtract 2g from here. This cancels out, and I'm actually left with 0 on the right-hand side. Don't panic about that. It's going to be okay in just a moment. Now we have 10g minus 2g, which is going to give me 8g. So I have 8g minus 7 is equal to 0. Now I need to add 7 to both sides to get rid of my 7. So now I have 8g is equal to 7. All right, now I'm going to divide both sides by 8. And then my answer becomes g is equal to 7 over 8. Again, fraction is fine for my answer. All right, on this one here, I need to do some distribution and then combining of like terms. So negative 3 times d, because I'm distributing it there, is negative 3d. A negative 3 times a negative 4 gives me a positive 12. Negative times a negative is a positive. Minus 5 is equal to 20. Don't forget to bring down like that minus 5 part, because you can't forget about things like that. All right, now I got to combine my like terms. So I'm combining my 12 and my negative 5, which is going to give me 7. So negative 3d plus 7 is equal to 20. Okay, now I can subtract 7 from both sides. And negative 3d is equal to 13. Now I can divide both sides by negative 3 to get rid of my negative 3. That cancels out, and I get d is equal to, and you can write this a couple ways. I can leave it like this with the 13 over negative 3. I like to actually put the negative sign on the outside and then put the 13 over 3. So it's a negative 13 over 3. And that's fine. You can leave it as the improper fraction, just as long as you reduce, but that one was already reduced. Okay, now we are going to look at this. It says 6 less than twice the number is 12. This is where you're doing those translations, okay? So remember, block off what you're doing. This is a test-taking strategy. Block off what you're going to do. I'm going to start with the word is, because the word is tells me that this is going to be an equal sign. Okay, I'm going to kind of write it underneath of here. Is 12. Okay, well, 12 is going to be 12. So the first thing I'm going to look for is the things that say equals 12. That means that F is out because that says it equals 6, and G is out because that says it equals 6. So now I've got down 50-50, right? I'm down to H and J. All right, let's look on the left-hand side then. 6 less than. Okay, less than, I know we're talking inequalities lately, but this is back to our, in this case, because we have the word is, this means equals. This less than is talking about subtraction. So it's 6 less than, there's my 6. 6 less than. Twice a number. Okay, twice a number means 2x, because it's 2 times a number. So it's 2x. Now here's the trick. Is it 6 minus 2x, or is it 2x minus 6? So we have to think about what we're doing there. Remember, 6 less than twice the number, that means that number is there already, and we're taking 6 less than it. So this is here first, so it's 2x minus the 6 is equal to 12. So I look up here at my answers, and it looks like my answer then is going to be J. The only thing is I used n instead of x, and that's perfectly fine to use a different variable. I like x. Next one here, Mariana wants to buy a new tennis racket. It costs $45. All right, I'm going to write that down. $45. Whenever I see math or numbers in my word problem, I'm going to write it down. She has $10. Okay, so she already has $10, and she plans to save $3 each week. Okay, there's a couple ways I can solve this. If we think about it as a checkbook almost, if I have $10 already, this is week 1. Or kind of week 0 actually, right? Because I have it right now. So in 1 week, if I add 3 to that, I now have $13. This is in week 1. I should make another column here. So I have $10 in week 0 to start with. In week 1, I now have $13 because I have 10 plus 3, which is 13. In week 2, I'm going to add another $3. That's going to give me $16. And I can keep doing this until I get up to the $45. Or I can do some math. If I already have $10, I'm going to subtract 10 and I get 35. Now, the $35 needs to be divided up by $3 because I'm spending $3 a week. So I'm going to take that 35 and divide by 3. 3 goes into 3 one time. 3 goes into 5 one time with a remainder of 2. And I'm actually going to use this remainder 2 thing here for a minute. So is she going to have enough money in 11 weeks? Or is it more than 11 weeks? This is the trick. She doesn't have enough money in 11 weeks. In 11 weeks, she only has $33 that she saved. Plus the 10 she already had, that makes it $43. She still needs 2 more dollars. In which case, then, it's not 11 weeks, so do not mark this one here. This is not right. It's not 11 weeks. It's actually going to take her 12 weeks to save enough money to buy the tennis racket. She'll have money left over, but it's still going to take her 12 weeks. You can't go into the store with less money than you need. Again, you could continue this table over here by just adding 3 each week. Week 3, and that would have been $19. And then you can kind of see from there how many weeks it's going to take you. All right, now we're talking about inequalities. Look at that word, folks, inequalities. Make sure you're highlighting the words. You don't get a highlighter on your test, but you certainly can mark it out with your pencil or make a little bubble around it or something, or even if you write the word again. Now, this is that weird thing where it says at least 7 movies. I hate this word. That always makes me crazy. At least 7 movies. That means that M is at least 7. So is M more than 7 or less than 7? If it's at least 7, that's the lowest it can be, is at least. That means that M has to be greater than 7. Now here's the other trick. Is it greater than or equal to, or is it just greater than? Can it be 7? And it can. It can be at least 7. It's like saying that I watched at least 7 movies this weekend. Or I'm going to watch at least 7 movies this weekend. That means I can watch 7 movies. That's great. But I might watch 8, 9, 10, 11, blah, 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 however many, right? So it's M is greater than or equal to 7. Again, one of the things test taking wise, do not just circle an answer, guys. Make sure you're actually writing it down like I did and think about it like I'm telling you. In your head, you're going to have to think about it. This is my correct answer there. Okay, which value makes the inequality 3x is less than 30? True. Now this is tricky. Let's solve the inequality first. This is the same thing we keep talking about. Let's actually solve it. I'm going to show you 2 ways to solve it. Okay, the first way we can do is literally to solve. 3x is less than 30. Okay, that means that I'm going to divide both sides by 3 because I'm going to treat this the same way I would an equation, doing the exact same thing. And so now x is less than 10. Okay, sorry, I lost my little recording thing. I needed to get it back. Okay, so x is less than 10. Now take a look up here, though. Look at our answer choices. We're saying here in our answer that x is less than 10. Okay, so x is everything that's less than 10, smaller than 10. But look at my answers. Everything says what? Everything says equal. Okay, that means that they're actually wanting a specific value that's going to make that inequality true. So x has to be equal to what then? Can it equal 10? No, because we clearly said right here that x is less than 10. So it cannot equal 10. This is out. This one's out. Can it equal negative 1? Well, I don't know. Is negative 1 less than 10? It is. So this one I like. I'm going to put a little check mark here. I like that one so far. Let's take a look at C. Can x be 11? Is 11 less than 10? It's not. This is clearly out. And let's take D. Is 84 less than 10? No, that would be a no. So that's out. That means that this is my right answer here. Remember, if you're having trouble with your symbols, to always go back and at the top of your page, if you need to, put the number line like so. Little 0 here. This side is positive. This side is negative. Remember, as you're looking at this right here means greater than, because all the numbers as they go to the right are getting larger. So this is greater than. And then this one right here is pointing to the left. This one is your less than. So if you need to, write that on your paper at the top and reminding you how to do those. Now, here's another thing you could do to make sure that this works, or if it works or not. I could literally take each one of my answer choices. I have 10, -1, 11, and 84, and I could plug it right in here. So that means 3 times 10 is supposed to be less than 30. That means 30 is less than 30. Is that a true statement? No, this is false, so that's out. That one's out. So we already said that's out. 3x, so again, 3 times -1 is less than 30. That means -3 is less than 30. Is that a true statement? Yes, it is. This here is true. And so this answer here is true, and we like this answer again. We can check it off again. We can continue for the other two, but for the sake of time, I'm not going to do that right now. But that's another way you could solve this problem. So think about doing it more than one way. All right, write the inequality that the graph represents. All right, this is pretty straightforward. We're going to use x, because I like x best, so I always use x. My arrow is going which way? This is the arrow that I have. So I'm literally using that symbol right here. That's the same symbol I'm going to put here. And I'm going to look at my, now I know my number here is right here. This is -6. Sorry, it's a little blurry, but it's -6. Is it greater than, or is it greater than or equal to? I have to look at the circle. The circle here, is it open or is it closed? If it's open, it's just greater than and that's it. If it's closed, I'd have to put the equal sign. It's not closed, so it's strictly greater than. It's all my numbers larger than -6 or greater than -6. Okay, now I actually have to solve and graph the inequalities. Okay, remember inequalities work the exact same way that equations work. So I have w minus 2 is greater than 1. I'm going to add 2 to both sides. This cancels out. I get w is greater than 3. Okay, so I just need to make them a number line. This is going to be 0, 1, 2, 3. All my numbers bigger than 3, that means I need to circle 3. And it's going to the right. My arrow here goes to the right, so I'm going to use this arrow here to the right. Darken in my arrow. And darken everything in between. There we go. So my answer there is w is greater than 3. Next one here. Again, I have to solve first. So I have x over -4 is greater than or equal to 4. I need to get rid of the -4, so I'm going to times by -4 on both sides. This cancels out, and I have x. But here's the trick. Remember, if I multiply or divide by a negative number to get my x, or my variable, I have to switch my sign. So this is less than or equal to -16, because I multiplied by a -4 right here. So that's going to be flipping my sign around. It's less than or equal to -16. Okay, so I'm just going to say that this is 0. I'm going to go ahead and just say that this is -16 here. I don't know how many things are in between there. So it's circling my 16, but it's also filling it in because it also equals it. My arrow goes to the left, so it's this arrow here. Color it in. And it's everything in between. Because it's all my numbers that are less than -16, but it also includes -16. All right, here we go again. Doing again another one. So I've got -6 is less than p plus 3. I'm going to minus 3 from both sides. And I get -9 is less than p. Remember, I subtracted. That's all. It's not multiplying or dividing by a negative number, so it just stays the same for the sign. Okay, so this was 0 here, -9. And it's all my numbers that are less than -9. There's my less than sign, but I got to fill it in. I circle my negative 9 because it's not including it, and it's everything in between. On this one here, I need to get rid of the 8. So I'm going to have 8 minus 12w is greater than 40. So I'm going to minus 8 from both sides. I get negative 12w is greater than 32. I now need to divide both sides by negative 12. This cancels out. Again, I divided by a negative number. So my answer becomes w is less than, I need to switch my sign, and this is going to be negative 2 and 8/12. When I reduce this, this becomes w is less than 2 and 2 times 4 is 8, and 3 times 4 is 12. So 2 and 2/3. Oh, negative, sorry. Now, the only thing is, I'm not going to have one like that for you to graph. But if we were doing that, if this is 0, 1, 2, 3, negative 2 and 2/3, this would be negative 2. Half would be right about here, and 2/3 would be right about here. So it would be right around in there if we had to graph this way. I'm not going to have one that's going to turn out to be a fraction, though. And it would look like that, because that would be 2 and 2/3. But don't worry, you're not going to have one that winds up being a fraction. This was just probably an oversight on my review for you. Okay, the next one we have here is m divided by 9 plus 10. So I'm going to subtract 10 from both sides. This becomes m over 9 is less than or equal to negative 14. I now need to get rid of the 9, so I'm going to multiply both sides by 9. I'm going to come down here to show the work. So m is less than or equal to negative 126. Again, we multiplied by a positive, so we didn't have to switch the sign. I just wanted to double check that. All right, so again, if this was 0 down here, then all the way down here might be like negative 126. It's less than or equal, so I'm going to circle and color it in. My arrow goes this way, and it's everything in between. All right, next one here, I'm going to get rid of the 6, so I'm going to add 6 to both sides. So negative k is greater than or equal to negative 8. Now we need to divide both sides by negative 1. Remember, negative k really has like a 1 in front of it right there. So I'm going to divide both sides by negative 1. This cancels out. K is going to be less than or equal to 8. Again, a negative divided by a negative is a positive. Don't forget to switch your sign because we did divide by a negative number. So again, if this was 0, this is going to maybe be 8 here. It's all the numbers that are less than or equal. So I'm going to circle that. I'm going to fill it in. Less than, and everything in between. Okay, we have which inequality represents 8 more than a number is no more than 13. Okay, we have the more than a couple times here, so we have to really think. 8 more than a number. In this case, this more than means an operation of subtraction. 8 more than a number. Now, this part is no more than. That's my inequality. And also, they give you a clue here, because look what they're saying. Which inequality? Not to mention, all of our answers have inequalities. In a way, they should have had some equations in there. All right, so also, it's 13 on the end. Now, that doesn't help us too much, because everything has 13 at the end of it. All right, so 8 more than a number. That means it could go either way, right? 8 plus n or n plus 8. Well, if you look at all these things, all of them are n plus 8. Now, here's the thing. It's no more than 13. That means it can go up to 13, but it can't go any further. That means it's going to be all the numbers that are less than 13. So here's a less than sign. I like this one. This is greater than. I don't like that one. Here's a less than sign. I like this one. And here's a greater than. I don't like this one, because it can be no more than 13. Can it equal 13? is no more than 13. It can equal 13, okay, because it's no more than it. It can equal it, but it can't be any more than it. It's kind of like that one about we did in the class about it can go no more than 65. I think I was equating it to miles per hour. So this is the answer we're going for here because it can also be equal to it. Okay, which inequality represents 4 minus 8 times the number is at most 50? Okay, at most, again, or is at most. This is that word that's going to be either the greater than or equal sign or the less than or equal to, because it's at most, meaning it's going to be also equal to 50. So actually, since we said that, it's also going to be equal to it. We know it's either this one or it's this one because it's got to be equal to. So 4 minus 8 times the number. So you're doing it that way. They all have it this way. 4 minus 8n is at most 50. That means, again, that's as high as it can go, is at most 50. That means it has to be all the numbers that are less than that, which is this one right here. Okay, this one here, it says Mario plans to spend no more than $60 for 3 shirts. Which inequality represents how much he can spend on each shirt? Okay, this is each shirt. That means for one shirt. So 3 shirts are 60. That means one shirt can only be up to $20. It says he spends no more than $60. That means at most, so to speak, he can spend $20 per shirt. So he can spend up to $20, but he can't spend more than $20. So that means that F, they're using F as the variable, has to be less than or equal to 20. It's this one right here. F is less than or equal to 20 because he can't go any higher than $20. Okay, so that's what we're doing on that one. Solve the equation. Make sure you're showing all your work. Okay, we need to combine some like terms here to get going. I can start either with my constants or I can start with my variables. I tend to start with the variables. That's just me. But if you start with the constants, that's okay. But I'm going to do 6x minus 9x. That means I have a negative 3x. And I'm actually going to go ahead and combine these at the same time here. Negative 12 plus 8 gives me negative 4. Because it's more negatives than positives. And all that's going to equal 17. I'm now going to add 4 to both sides to get rid of this. This is negative 3x is equal to 21. I'm going to divide both sides now by negative 3. And that gives me x is equal to negative 7. Remember, this is an equation. I did want to look back because we were just doing all that inequalities. This time it says equation, and yes, I want an equal sign in all of my answer here. So make sure you're doing that right. Check those signs. We're solving. Okay, again, equal sign. I need to distribute and then go from there. So 4 times 5k is 20k because 4 times 5 is 20. 4 times a positive 8 is positive 32 is equal to 2k. All right, well, I don't want the k's on both sides. I need to get rid of this. I'm going to get rid of the k from here, which means I need to take them away from here too. This cancels out, and I get 0. Don't panic about that. This becomes 18k plus 32 equals 0. Now I get to subtract the 32 from both sides. This cancels out, and I get 18k is equal to negative 32. I'm now going to divide both sides by 18. And I get k is equal to negative. And I can reduce this fraction here, but I'm going to leave it as an improper fraction. But I do need to reduce it in lowest terms. This is going to be 16 at the top because I can divide both of these by 2. So 16 over 9. So negative 16 over 9 is my answer right there for that. Again, you can leave it as an improper fraction. All right, we need to find the value of m. So again, we're going to do some math here to get rid of that. I'm going to add 5 to both sides to this. So this is gone. And I get negative. Actually, that's not what I'm going to do. Why did I do that? Nope, I take that back. I'm not doing that. Sorry. Let me do this again. Okay, on this one here, it's going to be a little bit harder to do than what you're going to have to do on your test, but it's worth going over. Kind of gets back to the ones we did in our practice the other day with our inequalities. So what we're going to do here, we are actually going to go ahead and minus the 5. This is going to be the easiest way to do it. We're going to minus 5 from both sides. This cancels out. And now we're going to have negative m over 2 is equal to 7m minus 5. Okay, I want to move the 7m to the left-hand side, so I'm going to subtract 7m from both sides. Okay. Now, negative m over 2 is the same as saying negative 1/2 m. Remember we talked about that before. Minus 7m is going to equal negative 5. And there's a reason why we're doing it like this. So now I'm going to make, I need to make 7m, though, have a denominator. I need a denominator for 7m. So this is going to be negative 1/2 m minus, minus 7 over 1 m is equal to negative 5. Okay, now I need a common denominator. So I have negative 1/2 m minus, and I'm going to make this a 2 and this a 14. Just make it multiplying both my numerator and denominator by 2. So I get minus 14 over 2m is equal to negative 5. Okay, we'll have a negative 1/2 minus 14 halves, which gives me negative 15 over 2m is equal to negative 5. I need to get rid of that negative 15 over 2, so I'm going to multiply both sides by 2 over 15. Excuse me, a negative 2 over 15. Because a negative, all that's going to cancel out and become a positive m. So I need to do the same thing over here. It's going to be over 1. So I'm going to times by a negative 2 over 15. Okay, all this cancels out. And a negative times a negative is a positive, so I get positive m. And again, a negative times a negative is a positive. And again, I'm going to simplify first. This becomes 1. This becomes 3, because 5 goes into both of those evenly. That means I have negative 1 times negative 2 over 3, which just gives me 2/3 right here. Okay, so that's how that one's done. Again, I really don't anticipate anything that difficult on your test. All right, next we have using our properties. We need to justify each step that we do. Notice it's all done for you, though. Okay, now you need to look at the properties to see which ones is going to go in here. Okay, so in this case we went from this to this right here. So they used which property? It was distributive. This is distributive property. Then from there we had, I'm going to have to use another color here to show you. They did this right here. So when I did this, this is my, this would be my combining like terms because I have a negative 20 and a positive 2. So I'm combining like terms. Oops, terms. And sorry, I need to pause again in a second because I lost my thing again. Okay, sorry about that. All right, now we have from here to here, we're also combining like terms because we moved the W and we've got it now down with this. So that was also combining like terms. Now we're going to do our additive or inverse by adding an 18 to both sides here. So this is an additive inverse, so we have to look and see what one goes along with that. In this case, it's going to be the addition property of equality, because I can add to both sides and I still get the same thing. And then our last step here, we're dividing both sides by 3, which gives us our division property of equality. So that's our one here, division property of equality. So those are those. So think of what you're doing. This is our multiplicative inverse, but we don't have that. So it's also dividing both sides. We've talked about that. So, and we can, whatever we do to one side, we can do to the other, and that keeps it equal. Here, the same thing. Let's take a look and see what we're doing with this. Okay, the first part here, we're going to add 5 to both sides. Keep in mind this time we have an inequality, so this is our addition property of inequality. And then we're multiplying both sides by 2 over 1 or by 2. So this is our multiplicative inverse, inverse property of multiplication. There it is up there, inverse property of multiplication. So that's what I would be writing here, inverse property of multiplication. What value of k makes this equation true? Circle the letter of your answer choice. Okay, so let's work this out. We need to get rid of denominators. Remember, anytime I have a denominator, I want it gone. So that means I'm going to times both sides by 2 over 1 or by 2 is the same thing. So this cancels out, and I'm left with negative 5y minus 4 is equal to 14y. Remember, what this is saying is 7 times y times 2. So I can go ahead and multiply the 2 and the 7, and that's okay. I need to get rid of the 4, so I'm going to add 4 to both sides. Oh, excuse me, no, I'm not. I'm going to get rid of the 14 because I need to move my 14 to the other side. So I'm going to subtract 14 from here, which means I'm going to subtract 14 from here. This cancels out, and I get 0. And then this becomes negative 19 minus 4 is equal to 0. I need to add 4 now to both sides to get rid of the 4. I have negative 19, and I lost my y. Wait, sorry, negative 19y. Negative 19y is equal to 4. I'm going to divide now both sides by negative 19 to get rid of that. And now I have y, I'm going to write over here, is equal to negative 4 over 19. So there's my answer right here. C is my answer. Okay, show your steps to solve the inequality and then graph your solution on the number line below, or you can make our own number line. So I need to solve this. I'm going to add 9 to both sides to start off with. So I'm going to add 9 to both sides. That gives me 6a is less than or equal to 23. I'm going to divide both sides now by 6 to get rid of the 6. I did not divide or multiply by a negative, so my sign stays the same. And then I have 23 divided by 6 is going to give me 3 times 6 is 18 and 5, 6. Or 3, excuse me, 3 and 5, 6, because 3 times 6 is 18. I have 5 left over. So that would be my thing there. To graph this, it would have an actual number that you're going to be able to graph, not the decimal answer. So I'm not too worried if you didn't graph this one. Now we need to, again, do the same thing here. I'm going to minus 16 from both sides to get rid of this. So I get 2w. And on this side is negative 9. Divide both sides by 2. So I have, and I'm going to leave it like this, negative 9 over 2. I divided by a positive, so I didn't switch my signs around. And that would be my answer. Again, it would be a whole number type of answer or an integer answer, not a rational number to graph, so you'd be okay with that. Here, this one is tricky. Okay, so we need to really watch this. This is the kind of problem that most people miss on their tests. I'm taking a look at what I have here, and I need to circle every single inequality that is the same thing, that means what this is. So let me look at my graph. The number here is negative 3. Okay. My arrow is this one over here. Okay, so that means that I'm saying that x, whatever my x value is, I'm saying that it's all the numbers that are bigger than negative 3. Or x is bigger than negative 3, excuse me. X is all the numbers that are bigger than negative 3. It does not include the negative 3. So I can't have the equal sign part in here, which is okay because none of my choices have that. They all have greater than or less than. Now here's the thing. If I have x is greater than negative 3, that means I can flip it around that negative 3 is less than x. Remember, that's the 2 different ways I can write it. Even though I always say write it the first way, we can write it with negative 3 is less than x. All right, so let's take a look at this. This does not work. Oh, actually, wait, maybe it does. Hold on a minute. I'm saying it doesn't work, but it might. Let me do the math, and let me make sure. X plus 5 is greater than 2. So if I minus 5 from both sides, that gives me X is greater than negative 3. Is that this over here? It sure is. That means that this is correct. Look at that. I almost didn't put that down because I wasn't thinking. All right, let me do the next one. Negative 2x is less than 6. That means I need to divide both sides by negative 2. That means that x is equal to negative 3. Oh, excuse me, not equal, excuse me. Sorry, is less than negative 3. Is x less than negative 3? No, that's out. Okay, let me do this one. Is x greater than negative 3? Yes, it is. That one works because that's what we just said. Is 2x less than negative 6? Well, I don't know. Let's divide. 2x less than negative 6, that means divide by 2. X is less than negative 3. Is x less than negative 3? No, that's out. Now we have, is negative 3 greater than x? No, negative 3 is less than x. Oh, look, here it is. Negative 3 is less than x. So those three answers should be circled on your paper when you do that problem. Okay, we are all done. That was the review. Again, sorry for any mistakes and all that I was running through because I was trying to go as fast as I could. Sorry that it is 46 minutes long. Remember, you can watch this in chunks. And again, I hope that you did this on your own first before you looked at what we did. Again, remember, most of your problems on the test will not wind up being so many fractions either. I hope you have a good night. Make sure you're studying. Remember, your test is next week. Good luck.